Around back there, okay? I'm just kidding. I love you guys.
All right. Well, with that, we're live for Hack Sunday. So make my way downstairs.
This mic here?
I'll help you out. Don't you worry, Ken. Everyone, welcome to Hack Sunday. Anybody whose first time it is, we're here on Sundays trying to figure out how AI is going to take over the world and how we can intercept some of that and hopefully do some good with it. Hopefully, whether it's in the medical arena or what I like doing, the AI production stuff. So that's what we're focusing on today. Today, you're good over there. We're focused on fine-tuning AI models for Rick and Morty. We're going to try and create our own Rick and Mortys here today. Stanley and Ken are going to be leading us. So with that, I'm just going to hand off to you guys.
Heck yeah, and Ken, I think, has some really cool stuff to walk us through, and I think everyone hopefully will enjoy. Definitely want to say before we start, though, this is such a cool use case. We'll be creating a digital twin of Rick and a digital twin of Morty and seeing if we can get them to write their own AI-generated Rick and Morty episodes. Definitely before jumping in, though, I want to mention this technology has a lot of utility in other areas because you can imagine any person, any community where you have a writing sample, you can create an AI that sounds just like that person, that community. So really exciting, and I hope this will just be the start of us exploring some cool ways to use these technologies together.
Yeah, thanks, Stanley. So just a couple quick things before we get started. The notebook is available on the ML2G GitHub. I just dropped the link to that in Telegram. If you guys want to follow along in your own notebooks, you can download that notebook and open it up in Google Colab. You could also open it up in VS Code or anything else like that. The only thing is you'd have to change some of the code slightly on the environment variables. With Google Colab, you can see right here, there's this little button, the keys, and that's where you're going to put in your AnyScale API key. So if you don't have an AnyScale API key yet, you can get one. There is a link at the top of the notebook to get it here. I'll make this a little bigger.
Shout out to the Google Colab team for finally shipping a feature after 8 years.
Is this big enough for everyone? Can everyone read the code?
You dropped that in the Telegram, yes?
I did.
It should be in the Telegram. Let's get it adjusted.
Better.
I don't see it.
You don't. Well, I hope I dropped in the right.
We got to find it.
Telegram.
Christina is our guinea pig. We got to get it to
Yeah,
her
it's
in her hands, everybody.
It is there.
And
It is right after your message.
take that, Christina.
The last
She's
message
always
was
heckling
from
you,
Jerry,
guys. I
so
don't know.
I'm in the wrong Telegram chat. Back
Oh.
user error.
But anyway, I also think too that for everybody using it on Colab, that's super positive. You know, Colab's such an incredible platform for kind of unifying effort in scientific research. And yeah, anyway, Ken has this beautiful notebook to walk us through.
yeah, I just want to give just a couple, more instructions if you haven't gotten an Anyscale API key yet. Some of you may have been here last week and already did that and maybe already trained a model with us, so you have one ready to go. If you haven't trained a model, it does take a little bit of time. So you could run that training run and then just kind of continue to follow along with an untrained model. It will kind of work similarly. I kind of designed the notebook so it could work with trained and untrained models. To do that, once you have that link, you'll log in. Anyscale does give you $10 in credits right off the bat. The only thing is I'm not sure that they are used. You are allowed to use those for training runs. I had to hook up a credit card to use it for training runs, but it seemed to still leverage my credits in the bill. But just an FYI, if you run into that, you may have to hook up a credit card.
Yeah,
But Anyscale is pretty cost effective. I think for like a Mistral model, it's like 50 cents for 1 million tokens. And for the Llama models, which we're using, it's like a millionth of a cent or something like that for 1,000 tokens. So
As long as you're not generating hundreds of dictionaries worth of text, you should be okay. At the same time, though, when we get to that point, we will talk a little bit about their pricing model. In particular, fine-tuning has some complexity to how they sort of allocate costs, which kind of makes sense because as we were saying, fine-tuning a model is really quite complex. You know, you're actually fully restarting the training on at least a subsection of the neural network's parameters. So anyway, it's just pretty incredible that Anyscale exists and gives us access to fine-tuning so easily. So, would encourage especially anyone in development to, I know it's annoying to sign up for a new service, but bite the bullet and make an Anyscale account. If you want to be part of building large language model driven technology, Anyscale is the main tool that you need. So, but anyone who doesn't want to make their own or has any problem with that, please just come up after and I would be happy to train some models for you on my Anyscale.
Yeah, that's a good call out too, because we are going to run through this maybe about 20, 25 minutes tops, and then we're going to be around to help you guys train your own models and make it work.
And anyway, just before we kind of jump into the code, it is so exciting to imagine what people will be doing with these technologies soon. I don't know if anyone likes Baldur's Gate in the audience, but it's just this incredibly rich narrative game that everyone's enjoying a lot right now. And you just imagine on the PlayStation 6 or the PlayStation 7, all of the characters are going to be AIs that you'll be able to talk to and create the same experience with.
Yeah,
so
definitely.
I almost feel like the tools that we'll be exploring today are the kind of the brush and paint of a new field of, let's call it personality engineering.
Yeah, that's a good way to put it. All right, so let's dive into this. If you guys have any questions live, feel free to ask them. Any issues with the notebooks, feel free to interrupt us. We'll be happy to help. Okay, so in this first cell here, we're just going to get some things set up. I have these commented out because I already ran them, but you're going to want to install OpenAI and datasets. Dataset is from the Hugging Face library, and that's going to allow us to pull in the data that we're going to use to fine-tune. Once you install those libraries, you're going to have to restart the session. So up here in runtime and restart and run all. And you'll want to have those recommented out when you do that. Once your imports are all set, You could get once your installs are all set, you could get your imports sorted. So just a few things here: pandas, OpenAI, transformers, Hugging Face datasets, as I mentioned, and a couple other things for displaying things in Google Colab and Drive. We're going to use Drive and mount Drive, so you will have to connect your Google account here. Mine's already mounted. What this is for is when we create the training payloads, we're going to push those actual files through the AnyScale API to run the job. So it's not just like a Python object, it's a full file.
This is just such a nice integration too. Thanks again, Google team. Kind of have your storage right there alongside your compute. One or two things to mention on the stack. So cool that AnyScale uses the OpenAI API. It's really easy to kind of migrate code back and forth from OpenAI to AnyScale. And then also Hugging Face, just so beautiful. And we'll be seeing how, Ken will be using Hugging Face datasets to build and operate with some pretty interesting training payloads. But also y'all can do the same. So if you even do a search for Hugging Face interesting datasets, you can, for example, probably find a data set of scripts from your favorite cartoon. So, for example, anyone who wants an AI SpongeBob or some AI Simpsons characters, you can probably find what you need on Hugging Face.
Yeah, and you could probably use a lot of this same script too. You'll probably have to adjust the transformations a little bit, but it should work with most data sets in the same format that Hugging Face takes. The Hugging Face datasets library is particularly for training models with Hugging Face. So for what we're doing today, we're going to transform that into a data frame. We're going to do some manipulation on that data frame to get the data in the right order that we'll need, and then we'll take that and turn it into a JSON L file, which is I think it's JSON lists. That is what the requirement is for loading a training payload into the OpenAI/AnyScale API. And you may notice me use OpenAI and AnyScale interchangeably. That's actually because in this context they are the same API, but with AnyScale, you're just changing the endpoint that you're pointing to, and then passing the AnyScale API as well. The benefit of that is that if you have code that you've written with GPT-3 or 4, and now you want to switch to open source models, it should be as easy as changing the URL that it's pointing to and the API key, and I'll show you that in a bit. So here's where we're starting the training process. We're grabbing our data set. This is the Rick and Morty data set right here on the train split. And we're transforming that into a data frame. And I'm just printing out this stuff in the first row right here to make sure that all worked.
And worth kind of wringing our hands just a little bit about that line, datasets equals load dataset, because again, that's using the Hugging Face datasets library. And Hugging Face has just this incredible library of data Alexandria where you can really find an incredibly diverse range of stuff ready to go. And so in this case, we don't have to point to a URL or anything. We just tell Hugging Face to go into Y Shawarma, which is probably some user, and then grab their Rick and Morty data set. So for people developing AI, Hugging Face is your GitHub and your tools for doing all this nonsense.
Yeah, and you'll see if I just run df.head to get the top 5 rows of the data frame. There is columns here with the season number and the episode number and the episode name and the character's name that's talking and the lines. So what I'm doing here is I wrote a little function that transforms that for us and gives us this output with prompt completion and the characters for each one. The prompt completion sort of paradigm is how OpenAI and AnyScale accept training payloads. There's always a prompt and then the completion, which is your desired completion. So if you're writing some custom training file, you would always have a prompt line and then a completion. And the completion is just what you want the model to say. So in this case, because we are training on just going to make it a little bigger for a sec. Since we are training on a transcript of dialogue from the Rick and Morty episodes, we designed the training file so the prompt is going to be one character's line and the completion is going to be the next character's line. And that's going to be kind of the way we're going to hack through this, because we don't exactly have prompts for each of the characters' lines. You could do this other ways and look back and kind of generate prompts for each of those lines if you wanted to, but this is a quick way to get us started.
And it's always important and interesting to think of what factors could affect your data quality, because once you build something, it's time to improve it and continue figuring out the dimensions of improvement. And there's a couple introduced in the fact that we are processing a script. For example, if a character has some lines that aren't actually responses to the other character, but maybe they're responding to a third character or something that's happening in the environment, that would probably be a lower quality prompt in our context.
Definitely.
So anyway, just so fun though, as we're kind of constructing a data set, we want to remember that really good AI comes from not just a static configuration of training data, but a kind of flexibly engineered set of training datas where you can kind of play the data piano in some different orders and different permutations and sort of learn exactly how different inputs leads to different types of intelligence.
Yeah, and there's different approaches you could have to training this too. For example, you could train a model that is specifically only Rick lines or only Morty lines, and you would kind of have to experiment to see what's better. This is an easier method to not have to do all that parsing out, but there actually may be a benefit to it where if the model actually has context of who was saying something before, it might actually be able to better produce a new line when you start calling it.
100%. And then even just before continuing to share just one aspect of where we can kind of see what we're doing and learn some more general principles about conducting machine learning operations that could be helpful in personal projects. The metadata of these training examples is so fascinating. So when Ken loaded up the training set, for example, it had the season that the script was from, right? So just even imagining that, people argue so much about, oh, that show really fell off after the second season. Imagine you could train an AI on the first season character and the second season character, and then kind of compare the way they sound, and then actually kind of explicitly be saying quantitative things about the way a show has changed over the seasons. It just opens up so many interesting dimensions of understanding personality and language. And then last thing, this is on a sort of medical data context. Imagine you were looking at the way a patient expressed themselves at a number of different points in time, and you had the ability to create different training payloads for the different states of a patient. You'd be able to do some really interesting things like talking to a patient when they're in a different state of being, kind of synthetically.
Yeah, very cool. So these are just a couple more utility functions here to split out the data sets by character if you need to do that. I think what we ultimately decided to do is just keep the prompt and completion characters as Rick and Morty only, but you'll notice in this data set that they have all the other characters that are in this season. So if you wanted to go back and train on everything, you could. It's going to be a bigger training file, and so it will be more expensive to run that. So for the sake of this, we just kept it to Rick and Morty, but you could basically do any character from the show that you wanted to with this data set. Okay, so I'm going to, and then just printing out the size of the data set is about 450 rows. So that's going to be how many examples we're training on here.
And it's kind of interesting too, because, again, thinking of this as like a very iterative process, when you're getting into the 400, 500 examples, like you're hoping that you're starting to see the rate at which the model is improving with data. And then you often are maybe looking to get up to a couple thousand examples for this kind of fine-tuning.
Yeah, cool.
If your goal is to get up to 1,000 examples, I mean, what sort of goals would you have in mind with those 1,000 examples of what's already been in the show? Is, different goals towards innovation, or it's just more towards, maintaining the memory of what's already been going on in the show? I'm a little confused.
It would just be trying to get better performance out of the model. So what we don't do in here is write an eval. But one of the methods that you usually use to test your model is you write an evaluation script, which you usually have a validation set. Usually there is a train set, a test set, and a validation set. For this, the purposes of this notebook, we just have the train and the test, or I think we use the word validation here. And that's actually kind of what this is doing. It is splitting out the sets into train and test. And what you would generally do in this context is you would see, okay, given a prompt and a completion that I know exists, if I give my new model that I just trained that same prompt, does it generate the same completion, or is there a sort of syntactic relevance to that completion? And that's what you'd want to see. As you get more examples, you might have some sort of score, let's say a similarity score, that would increase as you have more examples in the training run.
100%, and great question. And 100% worth kind of turning the dial on the detail of what we mean when we say similarity metric. Because again, this is a way of measuring how close two pieces of language are and getting a number for how close they are. But we know language varies in so many different dimensions that, exactly connecting the dots on what the training set is, what the validation set is, and then sort of how well all this is measured there's some real subtlety and some almost creative thinking involved. And then it is very fun, when you kind of look at a particular use case. So for example, when this thing is talking about the characters in the Rick and Morty universe, we probably want it to know who they are and remember how they're connected to each other and kind of say the right things about them. So, the failure modes would be like if it doesn't remember that Rick is Morty's grandfather and it says something different like Rick and Morty are cousins. But that's very different than like a coding copilot where, the things that are important for a coding copilot are more like where are the parentheses, where are the commas, like in a very specific way. So it's just all to say, like, even though there is a whole lot of code and math going on here, it really is something where you have to kind of use your English class brain to understand what's going on as well.
Yeah, absolutely. So because the OpenAI / Anyscale API does require a validation set to run the training job, that's what we've done here. So typically Hugging Face will allow you to pass a split on the data set when you load it. And usually you could say train, test, or val. For this data set in particular, it looks like whoever uploaded it didn't configure those things, so only the train set existed, and that is why I manually used another library to split the data set to the ratio of the test size being 0.2 or 20% of the full training size.
At this point, manually means like you only used 5 layers of automation.
Yeah, exactly. So that's what this is doing here and creating that train and test data frame. And now we have both here. And this is the creation of the JSON-L data. That is the data and the format that needs to go in to actually load a training payload. So you have this messages object here, which you may have seen. And this sort of takes in a prompt character and the completion character from those rows that we created and creates a system prompt and a role from the user and a completion. The user is always the prompt, and the completion is always the assistant. So you'll see in a little bit why this format that OpenAI puts us in does complicate this sort of dialogue generation that we want to do when you want to have two models talking to each other.
Yeah, I would even just kind of for developers in the audience and listening along at home, this is even just a cool example of something general, which is, you have your own objects. So in this case, Ken's built some really great objects to process and generate dialogue structures. And then maybe you have some, objects that are present in the API. And, sometimes you're kind of like, oh, how much can I create a one-to-one correspondence between these objects? How much, am I sort of working out the handoff and sort of isolating that so that it works well? But yeah, this is so cool and exciting. And then this is actually one of the things we're going to come back to and mess around with a little bit. Because, for example, you can see there's the system prompt, right? Your Rick and Morty dialogue generator, given the following character line, respond as the other character. It might be kind of fun to add some stuff there. Maybe we can say like, you're looking to write things that are very funny and in keeping with the style of the show Rick and Morty. And sometimes just those kind of English qualitative instruction requests have enormous impact on what these models create. So this will just be one of the dimensions where we can play around a little bit when we're done.
Yeah, exactly.
Oh, one last thing too. Anyone here ever had to write a high-performance JSON parser? No? Well, no, listen, we all do, right, when you get bored. But anyway, it's just kind of like so much of the world's data is stored in JSON, and JSON a very beautiful, flexible format, but very challenging to serialize in general because it can have such complex schemas. So JSON-L is actually just kind of interesting as an element of computer software history. People kind of got so tired of writing custom high-performance JSON parsers that everyone was like, I give up. Let's just put JSON objects in a list and call that JSON-L, so it's easily serializable.
Yeah, so prompt and completion here is basically synonymous with the user's message and the assistant's message, user being prompt and assistant being completion. So these next few lines of code are just transforming our data set into the JSON objects that we need, looping through that training DF to transform each line. And then we have this giant object here. This is just the first item that's going to have the training payload. So we then convert these to files. Here's the output paths, and here's just the writing of that file. So nothing too crazy going on here. And when you write a file in Collab, it automatically shows up here. So it's going to be very easily callable. And you could see in a second, here's me importing user data, which is where you can get your keys from. And then here's that set up with the OpenAI API. So if you've used the OpenAI API recently, we are using OpenAI. We just changed this base URL to the AnyScale endpoints, and the API key becomes the AnyScale API key. But other than that, it is exactly the same as working with OpenAI. So here are those training payloads that I talked about. We're just opening that file that is saved in here in Google Colab after running those lines above. We have the validation file and the training file. And then we're going to decide which model we want to train on. In this example, this was Llama 70B, but I've also trained a 7 billion parameter Llama model, and we could kind of experiment with the two of them. What I have found with the 7 billion parameter model is that its context window is only about 4,000 tokens. So you really could only generate about like 3 to 4 Rick and Morty lines with a system prompt, and it starts to hit up to that limit. So the 70 billion was definitely better, but it is a little bit more expensive to train and does take a little bit longer. But the one nice thing about this is that AnyScale handles the training on their cloud. So once you run this this cell right here, it's gonna already take care of the training. You could just actually continue. You could turn off your laptop, and the training is being taken care of in their cloud. And when it's done, you'll be able to run these lines of code here to check the status of that. But you could also go into AnyScale and look at, here's my fantastic invoice for training 3 models. So it's about $27. Definitely not nothing.
We have to return to this a little bit because AnyScale, I think, largely works with enterprise partners where they're kind of setting up pricing models through conversation. So there is some complexity in their pricing. It's overall not too pricey though. So and like I said, happy to train models for anyone. But yeah, so cool here we can see Ken's recent history of trained models. And again, to just kind of mention, so system prompt, something we're interested in messing around with, and then also model type. AnyScale is actually quite incredible at keeping up with the rapidly complexifying zoology of open source models. So they were very quick in adding the Mistral models, which are very big and exciting. But as you can see here, they also have the 7 billion open Orca models. And so you really can do quite a bit in sort of taking your data, trying a bunch of models. And this is really just like for machine learning operations, what the process looks like. Kind of understanding your goal, making quantifiable the accomplishment of your goal, like exactly how do you know when an AI is good enough, and then kind of figuring out each of these different dimensions of things you can vary, training data, parameters, model, blah, blah, blah. But anyway, so beautiful, so cool, and very excited to talk to these models, Ken.
Yeah. So I'm going to jump right back into the notebook, and we could start chatting with the models since I've already gotten them trained up. This first one, we'll try out the 70 billion parameter model. So I'm going to use the system prompt as you are Rick and Morty dialogue generator. Given the following Rick line, respond as Morty. So as I mentioned earlier, you could design this so you're training separate models to be Morty and to be Rick. By maybe just training on Rick lines and just training on Morty lines. The approach that I took was let's train on everyone and just prompt to get the right character. You'd really have to run some experiments to see what works better, but the intuition here was that we'd have more data, more context, and my experience with prompting is that this is exactly what it's really good for, so that this might work pretty well. And I think what we'll see in a bit is that it kind of does. So this first message, which is supposed to be from Rick, is Morty, we got to go. Grab the portal gun now, now, now. And I have this temperature up pretty high. 7 is going to be a pretty decent amount of randomness. But we could turn it lower if we want. I think for this sort of dialogue generation, it's a bit more fun to have a high amount of temperature because then you're going to get different outputs pretty much every time.
And, we covered this last time, but just to refresh people's memory, if anyone wasn't there, temperature is one of these really fascinating things called a hyperparameter that kind of sets the high-level behavior of the model. And in this case, what temperature does is it sort of, in predicting what to say next, it's how creative the model is allowed to be. So with really low temperature, you'll get like very sort of uniform and fairly uninteresting, you might say, responses, but are at least consistent and predictable. And then as you increase the temperature, it gets wacky. So obviously for Rick and Morty, I think Ken has made a very good hyperparameter selection there, my friend.
So as you can see here, when I dump out the chat completion result, you get this large JSON object with the ID from the model, this choices object, which has the finish reason and the index and a bunch of stuff here. What we really mostly need to access is the content. But you'll see here the role as assistant. If you have function calling and when you're using OpenAI or any scale, those would show up here. So these objects are like, in my opinion, a pain to work with, but you could see how there's a few things here that are kind of necessary to work with. As you build more complex applications with LLMs, specifically with this API, a lot of these other things do come in handy, but it can be a lot of parsing to go through, particularly if you're doing things like streaming and you have to kind of check each stream. But for the sake of this, we could just dump out the content, which is response.choices, where response is the completion object, .choices, the 0th index, the message, and the content.
And then, of course, these API responses in products often will have user interfaces, so these things can be used in products without being too complicated. But looking so good. And then here we have some code to actually generate, like some little generator functions, or?
Yep, exactly. So I wrote a little generator function here so we could more easily get out that content from the AI without parsing it each time. I'm selecting the model here, which is that 7 billion parameter model. The system prompt and the prompt is the same as the one before, but this just makes it a little simpler to kind of see how we would structure things. We would run that function, get AI response as a Morty completion with the messages, which is this object here, the system and the prompt, and then the model.
So I have, I don't want to rush at all, but I have some stuff I want to try to generate. I'm actually curious. Could we try a couple generations together?
Yeah, sure. You want to change up this prompt, or do you want to build the whole scene?
Oh, maybe I should wait to come back after we do the whole scene.
Okay, let's do that. Yeah, so for this one, it was, oh man, Rick, I'm not ready. I'm not ready to go on another adventure. I need more time.
I know that was me this week.
So with building a scene, there is a few more parts that we're going to deal with to make it more functional, more versatile, so you don't have to rewrite as much code for different scenes. So the very first thing is something I really love with prompting LLMs to get specific outputs is building characters. So there's a class here called character, and it lets you create a character card. And you could basically put anything you want in a character card. Generally, you want something like a name and a bio, but then you could have like a personality or other different attributes. And this is just going to be a JSON object that we're going to inject into our system prompt. So when we're prompting the model, it knows what the character is, what its traits are, and how it kind of should behave. So even though we did train on Rick and Morty, you may want Rick to, have his portal gun in that scene, and you want them to talk about it. So you could actually add specific things to this character card that allows you to get a little more flexible with how you want those scenes to generate. So what this does is when you create a character, you pass in its name, bio, personality, and attributes. That will create the character card. You could generate that character card with this function here, and you could then update the character card by passing in a new name, a new bio, personality, or attribute. And I'll show you an example here. So here we're going to say Rick is a character with the name Rick. The bio, mad scientist Rick Sanchez from the show Rick and Morty. And the personality is, just put loving grandfather. It could be anything. You could
Have you seen this show?
Well, hold on. There's an update down here.
I'm being so silly, bro, but this is so good. I love what you're doing here. And then this kind of distillation of a person into kind of their characters is so interesting, because if we can do this with one character, two characters, we can do this with a bunch of characters, get them all talking.
And that's the idea, because we could construct these system prompts in a more automated way, so we're not manually rewriting system prompts every time we want to generate a scene. We could actually write multiple characters and inject the character into the system prompt every time that character is talking, so the model knows specifically who it needs to behave like and how. And you could start to imagine how you could get really complex things with AI just generating all this, like if you had AI generating the characters themselves. So here's that example of updating the character. We're going to update the bio to secretly loving but outwardly madly insane, brilliant, genius grandfather who loves his grandson. And here's the changes in displaying both those character cards, so you could kind of see how it works out. I should actually update the personality, not the bio. Let's fix that real.
Have seen a number of people too use these kind of systems for some fun things. One of my friends has 5 AI characters who are software engineers from different disciplines. Like one of them's a data engineer, one of them's a DevOps person, et cetera, et cetera. And so he'll actually like ask them a problem and simulate the 5 AIs like arguing about what the solution is.
Yeah, that's exactly why I did it this way. I think this type of framework is actually really useful for building AI agents of really any type. And you might want each agent to behave in a different way. So if you have some sort of like market research agent, you might want it to be super inquisitive. And you don't necessarily need to train a model on that. You could just prompt the AI in a particular way to behave that way. And you could do that by creating these character cards. So a software engineer, you might want them to ask a lot of questions about requirements and things like that. And you might have these functions as like ask the user, and it would more often run those functions because in its character card, you're kind of saying you're a person that asks a lot of questions. So these are the kind of ways that you could create these larger sort of like armies of AI assistants. So here's the Morty card. He's typically nervous and easily distressed. Morty is Rick's grandson who often finds himself dragged into Rick's adventures. He's timid and moral, yet loyal to Rick, and his current attributes are courage under pressure, and a moral compass.
It's just so cool, man. And it's just that this is now engineering, that you're sort of engineering a personality, and that all of this is stuff we can adjust and play with. And again, personality engineering. Who would have thought we get to this place in the field?
We are. So the next thing that we have to build is a conversation object. Basically, that's just going to be a list, just a list of messages that we saw that we had to prompt the AI with to get a response. But as you have a conversation, you want to continue appending the last message to that list to get your entire conversation history. And it's not just the last few messages, that you could do it that way. It's really you want that whole conversation history, or as much of it as you can fit into the model's context, to be prompting the model. And that gives it the most context possible to have the best response. So this class essentially creates that conversation history with an empty string. We have a function to clear the conversation. We have a function to add message where you pass the role, the content, and that's going to generate that object for you that we saw before and append it. And then we are going to add another function for updating the system prompt. You'll see why this is important in a second, but depending on which character is talking, we want to change the system prompt because as you saw up here, we say, given the following Rick line, respond as Morty. So when you want to respond as Rick, you want to have that flipped.
I love to I'd love to be just a little playful and say that this is the short-term memory system for this personality that Ken has engineered. And so this is actually where you would go in to sort of modify and interact with how someone's short-term memory is processing what they're interacting with. So cool, though, man. Really well coded.
And this last piece here is just a function to display the conversation. And so now we're going to test this out. So I'm initiating a conversation here. And then I have this function just to clear the conversation. That's just for when I've gone down the notebook and come back to make sure it's starting from 0. But we're going to add a Rick system prompt. It's the same thing as before, but now we're injecting in the parts that we need. So Rick.name and Morty.name is just kind of an example. We're going to build our way up. So we're going to just add the Rick system prompt and the start Rick prompt, and we're going to display that conversation. And so we have the system message, you are Rick and Morty model generator, dialogue generator, given the following Rick line, respond as Morty, and then the first Rick line. So you'll notice here that we have user, because the roles always have to be user and assistant. We don't actually have them in there as Rick and Morty. Now, we could display them like that in our dialogue generator, but as far as sending data to the API, it has to go in this format.
And again, these are just those kind of questions I mentioned are good to think about as a very generalizable thing. When are my application data structures potentially dissonant with data structures present in the API?
Yeah, and so this is an example of doing that. So we're going to generate a Morty response given that conversation history object. And then we're going to add that message as the assistant, because at this point, Morty is the assistant responding. So we kind of have to keep that in the back of our head as we go through these different points of dialogue. When the model is talking, it is the assistant, and then when it's prompting, it's the user. And you see here's a bit of a funny one. After Rick says, Morty, we got to go grab the portal gun, he says, oh, man, okay, Rick, I think I got a good idea. I think we could use this bomb, the one that's attached to my back, and we could use it to our advantage. Make them think that we're crazy, and then maybe they'll leave.
I like that very much. And it's kind of interesting. It's came up with like a new story element. So
adding. You'll see, too, this is where the llama models get a little funky. We're just using the base 70 billion model right here. So what it actually started doing is it started generating the next line from Rick. So There are different models that you could use that might have better instruction tuning, or just the 70 billion model could help take care of that. But this is some of the quirky stuff that we used to see with like non-instruction training GPT-3 models, and even other models that didn't have a lot of instruction training, where they kind of like are still those document completion models where sometimes they just keep on running and don't stop.
Yeah, so interesting too, and again, it's just there's really this kind of intuitive or qualitative sense you get of how all these different factors come together. It's such a fun field right now. Ken, do we have a RIC 70 billion ready?
Yes, we do have a 70 billion
so
ready,
cool.
and we're going to use it.
Because I am thinking when we get to the question and answer phase, we'll be making a RIC system prompt that says, you just gave a talk on machine learning and you're answering questions. And then I think we should let the RIC answer audience questions. What do you think about
We
that?
could definitely do that. Okay, so now we're getting to our dialogue generator. There's a few utility functions that we have to build to use that dialogue generator. The first main one is that the swapping of roles. So all this function does here is that when I call it and pass the conversation history, it's going to return a swapped conversation history object with the user and assistant role swapped. And that means when we call the model and we add the message as assistant, then when I go to call the next model, I am first swapping everywhere that it says user and everywhere that it says assistant. So for that next call, it looks like the user is saying that, but we really know that that was the last model. And that's how you kind of get it to work, where you have two models talking to each other and the roles are in the right order. Here's a function to create character system prompts. This would inject the character card. As we previously talked about, you could really inject anything that you want into a prompt, and use kind of functions like this to dynamically choose which data that you want to inject in your system prompt, or any other prompt, really. Do you have something to say?
Oh, well, just so fun. And just to connect it, we were looking at the place where we were like, oh, we described Rick as a loving grandfather. Is that correct? Well, that's where that gets injected. So in the future, like as we maybe change that, try a different one, this is where we'll see that kind of ripple through the design personality.
Cool. Yeah. So I actually don't think I implemented using that. So here is that system prompt here. And in this case, I have both character cards being injected. So that's going to be our starting off system prompt. And then we're going to have a couple different sets of instructions. One for the first line, since there's not actually a first line there, we're going to have the model generate one. So we're passing a scene, a first character, a second character, a number of iterations for the conversation, and a model. So the scene also gets injected here, and that's going to kind of give the character something to go off, something to talk about. And in the case of the initial instructions, that will also be what's used to generate the first line. So we're going to add the system message as that system-based prompt up here. Then we're going to add a first user message with those initial instructions. So that's going to say generate the first line as whatever the first character is. Moving down here, I'm going to print out that first line. I'm going to generate that first line. I'm going to print it out. And then we're going to add that as the assistant. And then we get into our looping mechanism. So for the number of iterations we've defined, every even number, and that's what this is saying here, is going to be the second character's turn. And every odd number is going to be the first character's turn. That's just because we have two characters, and it's going to consistently go in that order. So what we're doing each time is we're updating the system prompt on the conversation history according to that character. So we're taking the base system prompt, this up here, and then we are adding the instructions. So if it's the first character, at the end of that system prompt, it's going to say, given the following line from the first character's name, respond as the second character. And what we're doing is just injecting those pieces to build the correct system prompt for our AI to correctly model the right character given the order of the sequence. And we're going to print it out. We're going to generate the output with that swapped history that I mentioned, swapping assistant and user around, and then we're going to print it out. So let's just take a look at what this looks like as an example of running it. So we're defining Rick as this character here. This is a much simpler version. We could change these up in a second and play with it. We're defining Morty here, and then we are setting a scene. So Rick and Morty are in the garage working on a new invention. We're going to just choose 4 iterations, and we're going to pass all these in. Are we allowed to curse here? I thought we're not.
Oh my gosh, model, you're in trouble.
Bad model.
We try to keep it PG, but then of course we want the AIs to be able to express themselves fully. So,
yeah, it does look like we got a couple duplications here too. I think we're still using that 7
have
billion
to blur
parameter
that out
model.
in post.
There you go. So the 7 billion parameter model does do some funky stuff. I've seen before we did see those duplications of the lines. Here it did not happen, but I think what we'll see is, and I'm going to just show the conversation. I think I seen.
And, I know many of us were goofing around with
There we go.
with the release of Sora this week, the text to video generator. When you start to think about generating something like this and then generating video and voice alongside it so that you actually could have like a constantly regenerating Rick and Morty episode going on, it gets pretty exciting thinking about where we're going to be in another 6 months, man.
It does, for sure. And see, even with the 70 billion parameter model, it was kind of getting these weird whoa outputs. But we do have that temperature turned up a lot, so we could just kind of keep running things to see what happens. But if anyone wants to give us some suggestions, we could, Stanley, I know you had some baked up that you wanted to try. Let's give it a go.
I was wondering if we could maybe load up Rick 70 billion and maybe modify the system prompt to make it like, Rick, you just gave a talk on machine learning.
So
and
that's
now
what the
you're
scene
answering.
is. So
Yeah.
all we have to do is pass the scene. So we'll say
So like Rick just gave a talk on machine learning and is now answering questions in a saucy way.
And is now answering questions in a saucy way.
Another thing I want to share just because it's interesting, and I think, Mary, you will maybe relate to this. Turn taking is a really interesting and underrated part of communication. It's actually so interesting, right? When you're talking to someone you vibe with, well, you kind of are able to hand off the talking stick sort of subtextually. And it ends up actually being like a key characteristic of conversation style, how long you take before trading off. I've worked for a couple companies where we created psychometric profiles of people, and then we attempted to predict how much affinity one person would have with another. And it turns out the average turn-taking latency is one of the biggest things that defines your communication style. So it's very interesting. I also joke that learning that kind of like broke my ability to socialize. Or at the very least, like when I'm talking to a new person, I'm very conscious of how long it's taking before we've handed off, which makes it really hard to hand off a conversation naturally. So I do not suggest anyone get into psychometrics.
So what I did here was I created 2 new Rick and Morty characters. I created Rick as a mad scientist, Rick Sanchez, genius, alcoholic, and sarcastic are his attributes. And then Morty is student and grandson of Rick Sanchez. He's excited, inquisitive, and naive. And then, like you said, Rick just gave a talk on machine learning and is now answering questions in a saucy way. So that scene and these character cards are going to get injected into this prompt in this way. And then based on who's talking, they're going to get these instructions to say their line. So let's see what happens. And it is the 70 billion that we're using. We just called this cell, so it should
And can we
run
give it a
that.
particular question, or should we just give it a shot?
Well, right now, let's see. Rick was generating the first line. So actually what I could do is switch this up because we may want Morty to generate the first line and then
Yeah, I think
Rick
that's the fun
answer.
idea is Morty asking Rick machine learning questions.
Let's just modify that. Morty starts the scene by asking
And
a
so excited also to
question
see that my good friend Rob is here today on this like relatively mellow Hack Sunday. And Rob is working on a platform that I would actually suggest everyone take a look at. It's called Infinite Tech. Maybe we could even get that shared in Telegram. But what it is it's kind of like a battle station for interacting with these type of systems without having to do all the code. Because like just imagine, like let's say you have your favorite scenes from Rick and Morty. Or maybe there's a certain type of scene or a certain type of expression that one of the characters does that you really like a lot. You know, imagine going through and grabbing your favorite parts of a show and then using that to build a data set that sounds like, you know, just the part of a character you like or just the kind of content that you like. So I'm really excited. I almost feel like in the future, our Hollywood showrunners are going to have this kind of battle station of all their different favorite linguistic examples, and they'll be kind of mix and matching these things to create new stories and new personalities.
Yeah, exactly. So it looks like I may have a little bug in the code that's getting this order mixed up that I'll have to take a look at. Because
do we maybe want to just do it as a Rick completion? Like we could just run inference on the Rick model?
Yeah, we can. I have some lines up here that we could do that with. So model, we want the 70 billion. Let me grab that. Okay. Okay, so we're gonna say your Rick and Morty dialogue generator given the following Rick, let's say Morty line, respond as Rick, and then we could say scene. I'll just grab that from down there.
Don't have it quite hooked up today, but I think for future scenes, we'll be able to show off also interfacing these kind of models with 11 Labs, which is like a voice generation system. So you could actually have like these lines voiced by someone that sounded like the voice actor. And potentially you could even speak back to it verbally and interact with the system like this verbally. And I have to say, like, we picked kind of a fun example for today, and you know, we'll be able to wrap up in just a little bit by asking it some machine learning questions. But yeah, the potential for this technology is really so incredible. And actually, one kind of small project we're working on is, you know, a friend of mine who's in education shared that for, you know, young people, like particularly in the 5 to 12 age cohort, in the LA Unified School District, who are bilingual and trying to improve their English language skills. Very hard for those people to have, for those students to have people to talk to. Very hard for a school to kind of staff enough teachers with the right language experience. So yeah, actually we're building a voice-to-voice bilingual AI system that could talk to a kid in both of the languages that they speak and sort of provide, you know, the ability to work on language skills through immersion for a bunch of kids who, you know, really might not have anyone to talk to who knows both English and their language of origin.
I don't know what that was, but
ask it hyperparameter, see if that gets it a little bit better.
Hyperparameter.
Wow. Well, that's a good answer from the perspective of being Rick accurate.
Fitting the Rick character.
I don't know if that's good machine learning science, though. Maybe if we took out the saucy.
Yeah, maybe the saucy is doing that. Okay, that's a good call. Scene.
Maybe we could change saucy for condescending.
In a
technical yet condescending.
Let's try sarcastic.
Run it again. Let's see. This is one of the interesting things too, is sort of seeing the diversity of what it will produce with similar
we have
inputs.
to clear that conversation history. I think I have to run that up there. Sorry. Oh, we are clearing the conversation history. Okay, so get rid of.
Man, well, Ken, such good.
There we go.
There we go.
Okay.
Oh, here we go.
Oh, I love that one, Morty. It's one of my favorites. It's a variable we use to control the parameters of a machine learning algorithm. I'm going to take the rest of these questions from the internet.
Oh, so cool. Well, anyway, so maybe let's just ask it one more and then wrap up. Maybe ask it, what does the temperature hyperparameter mean? And anyway, we'll also be kind of sharing these models too, so you guys can talk to your own Rick and Mortys. And then, and yeah, we'll be here for a little while to hang out if anyone wants to try to run the notebook for themselves or kind of, create some of their own agents.
Said, oh, Morty, you're so dumb. You don't know what a hyperparameter is. You don't know what a hyperparameter is, Morty.
Oh my God, too good. Well, Ed, do you have a question for it, or I think we're looking to. Yeah.
So I was wondering, is it on? I don't know.
Yeah, it's on.
Okay, it's good.
Yeah.
Doesn't sound like it.
Oh, it's definitely.
Test. All right. Well, in any case, what I was interested in is plot. How challenging would it be to integrate sort of the concept of a plot, a story plot, into the dialogue generator or the scene generator? So if you actually were trying to tell a story in addition to the dialogue.
It's a really good question, and I think too, like we're wanting to kind of disperse and talk some more, and so I can even share a couple really cool examples of where people have created plots in these kind of AI agent systems in interesting ways. Sometimes people do kind of like model the plot as a series of nodes and edges of like, the plot goes from this state to this state to this state to this state, and then they sort of like have the prompts change for the system prompt, like based on where it is in the story.
Yeah, exactly.
So there's a number of different approaches, but then you also see really interesting things like people creating data sets that represent the lore of a metaverse and then kind of training that into the models, which leads to some really emergent plot construction. But yeah, I do think this is really the layer that people are just starting to tap into. How do you kind of use these like elements of creation to create something much more complicated? And I think too, this is something, we will be exploring on future Hack Sundays. How do you use these tools to create like Hollywood quality stuff? Because we're going to be there so soon, everybody.
Yeah, you could essentially have, you could do it manually or have an AI create the plot. But you would have, parts of the story, and then you might want to define, based on the number of iterations in your dialogue, how quickly you move along that plot. And so maybe you have particular milestones in that plot, and you could say after every n iteration, you move to the next milestone. So you would probably dynamically update your system prompt to tell the AI where you are in the plot to give it the context. Because the whole point of anything that you inject in there is that the AI is context aware of it, so it could generate outputs that are, relevant to that point in time of the story.
Yeah, and anyway, such a good talk, and thank everyone for being here. And like I said, would be really happy to share some more examples and chat about it a little more. There's actually some particularly interesting stuff with like the intersection of fine-tuning retrieval augmented generation and storytelling, like sort of putting the plot in the RAG system, but then sort of tuning the model to interpret lore correctly when it says things. But anyway, thank you guys so much for coming to our third How to Train Your Llama talk. It was so much fun. And look forward to catching everyone again for future shows.
Cool.